one good day, Algebra. We are tackling PO44, the first of our three objectives talking about multiplying polynomials. And we're starting with what is kind of the most basic, which is a single term expression times anything, okay? And if you think back to the distributive property in PO10, you've actually multiplied a monomial by a binomial before, right? 7 is a single termed expression. 2x plus 3 is a two-termed expression. So you've done this. We just didn't call it that. Okay? So if you think back to PO10 and think about how you would multiply these two expressions together, distribute that 7 into the parentheses. 7 times 2x is 14x. 7 times 3 is 21. There you go. Okay? So it's kind of nice that we've got something we can kind of go back to and say, oh yeah, I've done this before. I get the process. It's just now going to be much more involved if you look at your homework questions. And so we have to pay attention more to that detail piece. What do you get when you distribute -8 into 3x plus 4? Gabby? -24x minus 32. Yep. Good. How about 5 times -3x minus 8? Josh? -15x minus 40. And Brent, the last one? -40x plus 90. Good. Way to catch that plus 90 there. -10 times a -9 is a positive 90. Okay? So if you look at the format of all of your homework questions are going to look like here, it's all a monomial, something on the outside, times parentheses. So this process of distribution, which is the review part, that's what you're going to be doing for all of them. The new part is what we have not covered in PO8, which is how do we multiply exponent terms. Yesterday and the day before, we talked about how to combine exponent terms with adding and subtracting. Okay, today we're going to cover that multiplying piece. And for whatever reason, Microsoft Word didn't like the multiplication dot that I had here. So you'll see 2 question marks on the first and the third. Just replace those with the dot. It's supposed to say that you are multiplying them. But for some reason, it didn't like that. Okay. So who can remind us all, when we learned how to add and subtract exponent expressions, what do we relate that to? What do we say? Adding and subtracting exponent expressions is kind of like this. Anyone remember? It was a great analogy. I was quite proud of it. Yeah. It was fractions, right? Because you needed those like terms, right? And then you added them or subtracted them, and that term didn't change. The variable and the exponent didn't change. Multiplication, being a different operation, has different rules. And that it's okay to multiply things that have different powers. And again, we kind of go to fractions and we say, when you multiply fractions, you multiply the numerators, right? And then you multiply the denominators. Do you need common denominators? No, just like you don't need like terms here, okay? But what we're going to be multiplying, and I'm going to show this to you once, and I bet you're going to pick up on the pattern here, but 4x squared in expanded form is 4 times x, right? We have a coefficient of 4. X squared means x times x, something times itself. And then we're multiplying that by 3 and then 4 x's, which represents x to the 4th. So if we break this down and say, what's actually happening here? We have 4 times x times 3 times x times x times x times x. And what we're going to do here is we're going to multiply our coefficients. 4 times 3 is what? 12. And then how many x's do I have total that are being multiplied together? 6. What's a shorter way to write 6 x's all being multiplied together? X to the 6th power, which would be our final expression. So can anybody see the connection here between our original and our answer here? How did we get 12? How did we get 6? Soybe.
So you got 12 by multiplying 4 times 3.
Okay.
And you got 6 by adding in 2 and 4.
That's exactly it. Okay, this whole part of PO8, multiplying exponent expressions together, this would be a great thing to put on a help sheet. Your basic strategy is that coefficients are multiplied and exponents are added. Okay, to multiply exponent expressions, those coefficients are multiplied, like we did with the 4 and the 3 here. And the exponents, the 2 and the 4, get added. So looking at that next one, negative 12n cubed times 2n to the 10th, we've got our coefficients of negative 12 and 2. They multiply to be negative 24. Our exponents, 3 and 10, get added, and we get n to the 13th. Isn't this smart math going on right now?
Yeah.
This is pretty good stuff. What about the third one? What do you come up with for that? 7n to the 7th times negative 2n cubed. Pay attention to this. It's all right here. All right there. Lauren. Negative 14n to the 10th is correct. Negative 14 comes from our coefficients, 7 times negative 2. And the 10th comes from the sum of our exponents, 7 and 3. Okay? And the proof for why this works, again, we're not writing them all out in expanded form like this, but that's why it works. You can clearly see you've got 6 x's there. If we wrote this out in expanded form, you'd see we have 10 n's there, all being multiplied together. The last one looks awfully fun. Okay? Our coefficients, negative 9 and negative 3, get multiplied to give us what? 27. And now we have 2 different variable bases. We have an x and we have a y. So we take our x's first. How many x's do we have in all there? 11. 6 plus 5. Then we go to our y's. How many y's do we have in all? Remembering that even though it's not written, that first y variable does have a power of 1. We don't write y to the first, but that's what just a y by itself means, y to the first. How many y's do we have in all there? 6. So 27x to the 11th, y to the 6th. And you've just learned an entire day's lesson worth in about 4 minutes and 15 seconds. So be proud of yourselves if you can see it and get the connection. If you don't, that's okay. You'll have plenty of opportunities to practice it below. It's not going to be, the whole page won't be homework. So if you are working ahead, maybe slow back a little bit so that you don't do more than you need to necessarily. Okay. But the homework here is essentially the combination of PO10 and PO8 because we're distributing into parentheses exponent expressions. And this is the work I want you to show. 7th grade really whined about it. I'm sure that you will not, right? But I want to see you distribute the 2x into 3x, and I want to see writing 2x times 3x and what that product is. Don't disappoint me. Don't start. What is 2x times 3x? 6x squared. 6x squared. Both those x's have a power of 1, and so 1 plus 1 would give us 2x's total. And then 2x times 8. Someone said it over there? 16x. Okay? And those two products, these two terms that we got, make up our final expression. So first we look, can I simplify anything? Are there any terms that can be combined? No. Make sure you write it in standard form so that 6x squared comes first and positive 16x comes second, and there is your answer. Okay?
You're gonna make us write out all the X's.
Well, I can't make you do it. I mean, if you don't, you're not going to credit for the assignment. But I can't force you. I'm asking you to do it. I'm expecting you to do it. Let's hop over to the last one in this first row because it's got some negative signs there and some extra fun. So we have 3x times negative 4x squared. I want to see this written out. Because like that, I mean, you learned how to multiply exponent expressions 3 minutes ago, and it took 4 minutes and 15 seconds to do it, right? So I don't expect comfort here, but this will help make you comfortable with it. 3x times negative 4x squared gives us negative 12x cubed. Coefficients multiplied, exponents added, 1 plus 2. Our next one, 3x times 3x gives us what? 9x squared, because we do have an x times an x there. And then 3x times a negative 12 is a negative 36x.
Look at my shirt.
Your final expression is these three terms put together in standard form. Negative 12x cubed comes first, highest power, followed by negative, not that. Really, I almost made it to the end without a big mess up. Let me come, there we go. Followed by positive 9x squared, and then negative 36x. Okay. We'll do one in the bottom row, or the second row. Let's do the middle one. That's 6x to the fifth. So we have 6x to the fifth times negative 2x cubed. And here's where you might really need to think. Okay, coefficients multiplied. 6 times negative 2, negative 12. Powers added. X to the fifth times x cubed, 5 plus 3. That gives me x to the eighth. Then 6x to the fifth times 9x. 6 times 9, 54. X to the fifth times x to the first is x to the sixth. Then lastly, 6x to the fifth times negative 4 equals negative 24x to the fifth. Our exponent doesn't change in this case because that negative 4 doesn't have any x's with it. So our final expression is going to be these three terms put together. Negative 12x to the eighth plus 54x to the sixth minus 24x to the fifth. Okay? Your homework for tomorrow is just the first two rows. So the three that we did not do in class are the three that you need to do for homework tomorrow. So I am asking you to show a fair amount of work, but it's only 6 total questions, 3 of which have already been done for you. So I think it's fair. All right. If you want to work ahead, you see that the ones after that become a little bit more meaty. If you want to work ahead, be my guest. But for tomorrow, just the first 2 rows. Any questions before we sign off? Okay, very good. With gusto, that is how you math.
Don't forget to like and subscribe.